right, so the last lesson in this unit on functions and relations are the graphs. All right, so graphs of relations and functions. All right, so in the first example here, we want to determine which of the following graphs represents a function. All right, so I got one graph here and another graph here. Okay, so first thing we want to do is just make clear that you know what a function is. Okay, so in order to be a function, so remember, a function is a special type of relation where you can only have one output for each input. All right, so again, output and input, another way to think about it is only one output. So this is your y variable. And your input is your x variable. All right, so in other words, the y is your a y-axis, right? So you guys are used to seeing it as the vertical axis, which will always be the case. And your x variable is your horizontal axis. All right, so what does that mean in terms of a graph? So here, you can see here that at 7, right, there's 1 point. At 7.5 shoe size, there's still 1 point. However, once I get to 8.5, I go up here, you can see that there's 2 vertical lines shown up. What this means is that at 7 or 8.5 as a shoe size, there are 2 different heights, which we cannot have. And likewise, at 9, shoe size of 9, we have 3 different heights. All right. So what this is, since this is my x and this is my y-axis, the vertical one, we cannot have 2 y values or 2 outputs for an individual input. Right? So in this case, this is not a function. All right, since like if I even wrote these points as like ordered pairs, right? One would be 8.5 and 170. And we also have 8.5, 175. All right, so here we have this one input has 2 different outputs, which would no longer make it a function. All right, and it's also true over here too, right? This time we have 3, but it just has to happen once. So there's something called a vertical line test. So we'll go right down here. Line test. Right, so this a vertical line test will tell you whether a graph is a function or not. Right, so I'm going to write this out in actually my own words. Okay, so if the graph crosses a vertical line twice, sorry, not twice, vertical line more than once, it is not a function. Is that what that means is that you'll have 2 outputs for 1 input or more. Okay, so so if I was to use, say, a highlighter here, right, let's just say I draw a vertical line, this is fine, but right here, you can see that the vertical line here crosses, these 2 points cross the vertical line, likewise over here. Okay, so that's, in that case, this is no longer, this place right there, that makes it no longer a function. Right? Right, because again, we cannot have 2 outputs for the same input. We cannot have 2 different y values for the same x. Okay. So let's go on to this one here. This graph here, right? If I drew a vertical line, there's no vertical line I can draw that will cross a point more than once. So therefore, this is a function. Okay. So hopefully that makes sense. All right. Now these 2 questions in this example are dots, right? They're points. But it's also true for just irregular kind of graphs, right? So if I was to draw something like, say this is my graph here, then something like this. Okay, so this is a function. All right, the reason for that is there's no place here where if I was to draw a vertical line, it would cross twice, right? However, if I was to again, draw a function, everything's going along fine, and all of a sudden I kind of come back like this. This is popping up there at once. This is not a function. All right, so the reason it's not a function is because I can draw a vertical line right here where you can see that it crosses more than once. Okay, so that means you have 3 different outputs here, the same x value, which we cannot have. All right, so this one fails the vertical line test, whereas this one is okay. Cool. So, all right, so that's how you tell whether a graph is a function or not. All right. Next up, determine the domain and range of the graph of each function. Okay, so this time, yes, we are going to be looking at domain and range. Okay, so and this is a very important concept that you really need to have a strong handle on. Again, when it comes to not only this course, but as you move along in pre-calc 11 and pre-calc 12. All right. So domain and range. All right. So domain is the set of all input values, or in other words, x values. Whereas the range here is the set of all y values. All right, so I'm going to do my best here to explain using this as a function here, how to find the domain. So basically, when it comes to x values, right, the x-axis is along here, the horizontal one is the x-axis goes left and right. All right, so what we want to do is just imagine that we are running a scanner left to right. And we want to see where is there a function. So the first thing actually I need to point out here is that you'll see on this graph, you see a dot here. All right, so that means that the function kind of stops here. Because the graph stops here, obviously it stops here. Right? Now, the other thing though, on the flip side, if I come back up this way, you'll notice there's no dot here. So what that means is that this function itself actually doesn't stop. Right, the graph stops, right, to show you a picture, but this thing actually will, if I was to continue drawing it, will actually go on like in this direction. Okay, so I just want to point that out. And then, so I can't draw this obviously forever, so I'm just going to draw a little arrow there. Right? So ideally, actually, let's go back to this. If I was to erase that, ideally, you would have done this. Draw an arrow there. Okay, but that's just be aware of that. Okay, so if you see that in the textbook where there's no dot, that just means that there should have actually been an arrow drawn there. And this indicates that the graph itself obviously will go up forever, but it also goes to the left forever. All right. So yeah, those two things. So up and left forever. All right. So if that's the case, I want to figure out what the domain of this is. So if I ran a scanner left to right, this arrow means that no matter, just because the function has been drawn onto this grid, doesn't mean it ends, right? It goes like, ideally, it will go left forever. So in yellow here, highlighter, I'm just going to kind of draw this yellow line here. Now, this function goes down and it comes back up, but it stops here. But I'm only concerned when it comes to domain, I'm only concerned with going left and right. So hopefully this makes sense that the function is there's a function over here in the yellow, but there is also a function until it gets to that point right there. All right. Then from this dot on, if I were to go left, right, there is no function here. There's none forever. So it stops here at. So if it stops here at 3, right? So basically, as a actually domain here, I'm just going to write a 3 here and just draw an arrow this way. If you were to describe this in words, the domain is x is less than 3. All right, I'm going to put that in quotation. Now what I'm going to do is actually show you how to write that in like notation wise. So this is where we, I believe you guys have a background in inequality signs, right? So if I wanted to write this kind of quickly, rather than writing out all the words, all right, I'm going to just say domain is less than 3, yes. So x, and you guys remember the inequality signs? So that is less than, okay? X is less than 3. So if I was to read this out, it would say x is less than 3. So this is what you need to get used to, is using the notation in terms of inequality signs. All right, so again, hopefully that makes sense. All right, domain is again the set of x values. So you're always going left to right. So where's the function if I go left? If I ran a scanner left to right, well, there's a function everywhere until it gets to this point. You know what? Actually, perhaps this will make it a little bit clearer. If I was to actually color in most of this, you can see that as I color all this in, there's a function. If I was to run a scanner left to right, there's a function in that yellow area, okay? But then it stops right here. That's why the domain here is x is less than 3. All right, now the range. So if domain is left to right, the range is up and down. All right, so I'm just going to take a second here and just erase this highlighted part. That's not going to help us when we're trying to find the range. All right, that's part 2. All right, so okay, so now if you imagine going as a scanner, if I was to go up and down, this arrow means that there's a function up here. As well, there's a function, it goes all the way down till here, right, to -1. There's no function below here. Okay, so if I ran a scanner up and down, in yellow here, I'm just going to shade this, color this part in. That was terrible. Let's erase this part. Oh, I erased the whole thing. Ugh. Okay, guys, I'm missing this. Sorry. All right, so you can see that the low point is right here, but then there's a function, and it goes up forever. Color that in. All right. So if I was to go up and down, you can see the low point here is at -1. And then there's a function everywhere above it. So the range is going to be y is greater than -1. So I'm not going to write that out in words. I'm just going to write the notation wise. So range is y is greater than -1. Okay, so that is the domain range. Okay, so if I ran a scanner up and down, the low point here is at -1. Okay, so again, domain left and right, range up and down. All right, so let's take a look at this one over here. This one I'm going to do a little bit quicker. Actually, I just realized I'm not going to do it a little bit quicker because I need to explain another thing. But anyways, all right, so if I wanted to figure out what the domain, so if I ran a scanner left to right, you can see that this graph goes up and back down, but if I ran a scanner, it would be from -2 to +2, right? If I ran a scanner left to right. So in words, I would write between -2 and +2. All right, now notation-wise, if I ever want to use the word between or show the word, describe a domain as between two values, the way you write it in notation is -2 less than or equal to x less than or equal to +2. All right, and I'm going to explain why right now. Okay, so this describes between two numbers. Now the key thing here is you put the lower number first, these signs will always be less than or equal to, and the greater value, maximum value. Now, the other thing you'll notice is I said less than or equal to on both of these. The reason this is the case is because this is solid. All right. So you may actually come across graphs that look like this, right? So if it's a hollow dot, this would be strict inequalities, that they say. So if the dots are shaded in, it's less than or equal to because you're including that value. If they're hollow dots, then you just put strict inequalities there. All right, so now, why does this mean between? All right, so what I can do is I can break this down. So I can break this down into two sections. I'm just going to use a red marker here. So the first section here, let's just ignore this part here, which says less than or equal to 2. Let's say I want to just draw -2 is less than or equal to x. All right. Or in other words, if I read it the other direction, right, x is greater than or equal to -2. So on a number line, if I wrote down -2 here, if I just wanted to draw this part here that I circled in red, again, this means that x is less than or equal to -2. If I wanted to describe that, I would just put a dot here, and then x is greater than or equal to -2 would be in this direction. Now, let's say, now I want to describe this part in green, right? So if I read this here, so ignore the red box part and just look at the green here. X is less than or equal to 2. This is 2. X is less than or equal to is this way over here. All right. Now, what if both of this had to happen at the same time? If x had to be x has to be greater than or equal to -2, or less than or equal to +2, well, that is where these two lines or two sections would intersect. And you can look here, what I shaded in is between -2 and +2. All right, so this is just an explanation as to why this is the notation for between. All right, you always write the lower number first, less than or equal to, so the signs will always go this way. X less than or equal to +2. All right, so what I'm going to do too here is just erase the box. Okay, so so the domain in this case is, I'm just going to put a box around it there. All right. Now, what about the range? Okay, so the range here you can see is if I ran a scanner up and down, right, it would be here to there. Right, down. So this is between 0 and 2. Now, rather than writing out the words, I'm just going to jump straight to it. So again, I said between 0 and 2. So 0 is my smaller number. So 0 is less than or equal to y is less than or equal to +2. Okay, so this notation here describes y is between 0 and 2, which in this case would be the domain. Or sorry, range, which in this case would be the range. All right. Cool. All right. So that's domain and range. That's how to determine whether a function or a graph is a function. Cool. Just